All right, we're going to get started. It is my pleasure to introduce Dr. Brent Gary. Dr. Gary is a planetary volcanologist. He's with the Center for Earth and Planetary Studies at the Air and Space Museum at the Smithsonian Institution in Washington, D.C. He studies volcanoes on the Earth, Moon, Mars, and now asteroids as well. He's a participating scientist on the Lunar Reconnaissance Orbiter mission, as well as the Dawn mission, which is studying the asteroid Vesta. He spends a lot of time doing field work in New Mexico and Hawaii and a variety of other places that he'll probably, I don't know if he'll mention a little bit in his presentation. And another thing that he does that's really interesting is he is a member of the NASA Desert Rats team, which RATS stands for Research and Technology Studies. And this is the group that is currently testing the next generation rover called the Space Exploration Vehicle that maybe one day will make its way to the Moon or Mars. So, one more interesting tidbit about Dr. Gary. He was a camp counselor at Space Camp for several years as well. So, with that, I will turn it over to Dr. Gary. Thank you.
Good evening, everyone. Can you hear me okay? Okay, great. Well, thank you for coming out to International Observe the Moon Night. Again, my name is Brent Gary, and tonight my goal is to take you on a journey to the moon, but set in your backyard. Okay, I'm going to talk to you about what was it like if the astronauts that went to the moon during the Apollo missions, what if they actually landed in Washington, D.C.? Where would they go? What could they see? Okay, so with every NASA mission, you have to have a launch. So who wants to be my PIO officer? You, come up. Every launch, you guys come up. So every launch has to have a countdown, right? So what do we start with? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Off to the moon. Okay, great. Oh, there's no sound effects. Okay, so this is our launch. So this is the Saturn V taking off, launching folks to the moon. Thank you guys. You guys get a free lollipop. Anyways, good job. Okay, Saturn V taking off to the moon. So what if Apollo landed in D.C.? What monuments would they get to see? What museums would they get to go visit? You know, how much of the city would have been explored by Apollo 11 compared to Apollo 17? Okay, there were 6 moon landings that actually, 12 people have actually walked on the moon. What would they get to see if they are actually going to D.C.? Now, going to the moon is a lot like planning a family vacation. Okay, you have this cool, wondrous spot you want to go visit, but where do you want to go? You want to go see the romance of San Francisco? Maybe get some fresh air out in the Grand Canyon. I know, I would love to go to Walt Disney World myself. Maybe you want to go do some cool patriotic stuff up in New York City, or learn about, the history of America right here in D.C. So you have all these cool spots to choose from, but where are you going to go? You finally settle down based on your budget and your time constraints, and we're going to just choose D.C. for the sake of tonight. Well, the people, when they chose to go to the moon, they had the same problem. All these geologists got together. We're like, we have this whole wonderful moon to look at. Where are we going to go? And we have such a short time frame to go. So they had this whole place to choose from, and eventually could only choose 6 spots. Okay, so where are you going to go? Did you want to go to craters? Did you want to go to the mountains? Did you want to go to the volcanic channels on Aristarchus? Where could you go? So they had that same kind of conundrum, and eventually they had to choose a few different spots for them to land on. Once you make your decision of where you want to go, you want to do your reconnaissance. You want to do, kind of plan ahead, look at the guidebooks, talk with people who've been there before, look at images. So then you can start planning out, hey, do I want to go visit the Washington Monument? Maybe I want to go do a tour of the Capitol. Maybe I want to hit Air and Space Museum. Maybe look at some art. Maybe even make your way up to the zoo. But where you want to go also depends on how long you have to travel there. Are you there just after a business meeting? Do you have 2 hours in between your flight at Reagan to maybe hit one museum? Are you visiting your aunt and uncle for vacation? And do you have, a few days or even a few weeks to spend your time exploring the city? Okay, so Apollo had a very limited time frame. Okay, they did recon by sending in these different types of satellites and landers. So this one actually just crashed into the moon. It took pictures on its way down until it crash landed. The lunar orbiter missions actually spent time orbiting and mapping out the moon in detail. And then they even landed a few landers on the surface of the moon to figure out the soil properties and a few other aspects of the moon. You can see this one here was visited by Apollo 12. Okay, and these plans and all that data from those missions were used to create plans for the astronauts. So here's an example of a cuff checklist. This was like a little book that was on the arms of the astronauts. And on the left, you see, look, it's a map. Okay, this shows them a map of where Apollo 17 is going to go from Station 3 all the way up to Station 4. And I actually drew in some of the features here. But they also had a very, a very tight schedule. Okay, almost like the type A dad who's like, we have to be at the IMAX movie at 2:35 promptly, so we can pick it. So as they're closing out of here, they only had 17 minutes to get to Station 4. Not 15 to 20, not 10 to 20, maybe 30. They had 17 minutes. They were on a very tight time constraint, and they had these checklists with little hints of what to do as they go to keep them on their time frame there. Now, once you get to your site, you got to figure out, how am I going to get around? Am I going to use the 2-foot turbo? Is someone else going to drive me? I'm going to make someone pedal and work, against gravity, and bicycle around. I'm going to take public transportation. So you got to figure out how you're going to get around your location, where you're going to be. You also got to figure out how much stuff you got to carry. You have your life support system, your camel pack, your backpack, with your food and your drinks and your munchies. You also want to show your friends, on Facebook and Twitter. You have your camera to prove that you were there. You also you want to collect souvenirs, just like the astronauts wanted to collect rocks. You got to show, you want to bring something back, I love DC or something, a CIA or FBI t-shirt or hat. And then you have what I call the barrel of monkeys. That's everything else. Okay, that's, your umbrella, your rain jacket, your gloves or something. Stuff you might need, but you might not, your little brother or sister. Things you might take with you, but if you can leave it at home, you would. But, you got to bring it with you. So all these other little things, games that you might play, so little knickknacks that you have to carry with you. Apollo had a ton of stuff they had to get there. That's why they had that giant rocket. So they had, not only did they have their suits they had to carry with them, they had the landers, but they had scientific instruments. They had flags. They had TV cameras. They had very small little receptacles collecting very small rocks. They had cars. Holy moly, lunar rovers on the moon. Okay? And they had giant, almost suitcase-like things with their tools and their sample bags for them when they collected the rocks that they had to drag behind them. So they had a ton of stuff, not only that they had to use to get up there, and sometimes they used everything and sometimes they didn't. Now once you plan your trip, you figured out where you want to go, so you hit your hot spots, okay? You figure out your points of interest, you mark them, and then you maybe make a map, like a preliminary traverse of where you want to get to, okay? Let's, start at the Washington Monument, head up, have, lunch with the president, come around, say hi to Lincoln, maybe skip over and say hi to Jefferson, and maybe hit a few museums before we have to head out. But when it comes to reality, not everything happens. You might be dragging your little brother through the reflecting pool because he's tired and slow. So you might have to not get to go see Jefferson. You might only get to see a few museums. And you might have to, catch a cab up between the art gallery and, the White House. So plans change. So you have to be flexible. So you have what you hope to do, but then you have what really goes on. This happened in Apollo. They had plans of where they wanted to go at each of their landing sites. So here in red is the planned lines for where they wanted to go during the Apollo 17 mission. And in green, you can actually see where they actually went. So if you look at their first EVA, it got cut a little short. They didn't get to go all the way down. But EVA number 2, they actually followed it pretty well. But look, it's not exactly a straight line. They're kind of bumping around all over the place because, there's different craters and different, objects and artifacts and places that have to kind of weave around while they're driving. And some of over here on the third EVA, they had to miss that a little. Now here's the landing sites or traverse maps of all the different missions. Okay, so you have Apollo 11 at the top, which was the first one. And then, but what I want you to notice is the scale bar here. So all these lines look kind of similar, but go from 20 meters, 200 meters, 500 meters, 2 kilometers, okay? The changes of scale and the distance that these different traverses or, missions covered changed between the first and the last mission. They just got more and more complex and were able to reach out. And these bar graphs kind of illustrate that. Early ones, the ones in yellow is Apollo 11, Apollo 12 and 14 are in green, and 15, 16, and 17 are in purple. Now, if you look at the total number of EVAs, the first mission only had 1 EVA. That means they only went outside of the spacecraft once, once they landed on the moon, 1 moonwalk. Apollo 12 and 14, they had 2. As it got to 15, 16, 17, they had 3. But that's it. Maybe a total of 14 moonwalks total. And then the entire Apollo program. Look at many hours he actually spent outside on the surface. About 2.5 hours for 11, under 10 hours for 12 and 14. It wasn't until 15, 16, and 17 that you actually got above almost 20 hours. So between the last mission spent about 10 times as much time on the surface as the first mission. Amazing. Look at the distance they covered. Down here, you can barely see where Apollo 11 walked. They've just walked a few hundred meters away. 14, 12, and 14 didn't even make it, maybe to 5, 10, 5 kilometers away in total distance. But then you look, 15, 16, 17, you're hitting over 20 kilometers, over 30 kilometers in distance. And the blue bars are in miles for those of you who know kilometers. And then look at the number of rocks they collected from the beginning to the end. It just keeps growing and growing and growing. Okay, so let's look at Apollo 11. What if they landed in D.C.? So here they are. Here's the crew up in the upper right. Here's an LROC image of where the landing site. You can see the lander right there, where the TV camera is, where some of the science experiments are. But let's put it on the mall. Okay, here it is up here. It might be a little hard to see, but you can see the lander right there. Down here is the National Mall. You have the Smithsonian Castle right there, and these are those big grass patches. There's the Smithsonian Metro exit. If this black spot right here is the lander, this is what they would have covered. Barely the inside of a baseball field. Okay? They would have, Little West Crater would be right here, and they wouldn't even make it to the path, the side paths where people go running and walking all the time. And they wouldn't even be able to make it to the side streets or any of the museums. That's all they cover. That's Apollo 11. Here's a view of it from the ground. You can see where the experiments would have been and where they would have landed. You can see the Washington Monument off in the distance. But just to give you a view of what Apollo 11 would look like. They wouldn't even left the National Mall. Apollo 12, the second landing. This happened in November of that year. So you can kind of make out some of their tracks. Here's their Intrepid descent stage. Here's where they put all their instrument packages up by the ALSEP. And then they walked around all these different craters through here. You can kind of make out the arrows. And then they visited Surveyor. Here's Surveyor. Here's one of the astronauts by Surveyor collecting pieces of it to take back with them. Here it is on the National Mall. So we kind of put their landing site right next to the Washington Monument. Okay, so they did 2 EVAs. So their first EVA would have taken them up to about the American History Museum. And their second EVA, and when I put the craters in there for scale, they would have basically traversed all around that mound where the Washington Monument is. But that's about it. That's all they would have been able to do is just, so next time you walk around the Washington Monument, you're essentially completing EVA number 2 for Apollo 12. So tell yourself that. Hey, look, I'm on the moon. I'm on an EVA. And Surveyor would have been off to the sidewalks here and stuff. And here's a perspective view. So head crater would have been off to the left. The LEM would have been off to the right. And right behind the little white building right here, they would have, put their package on the grass over there. There's scientific instruments. You can see the Capitol way in the distance. They wouldn't even got to go visit the Capitol. They would just had to view it from afar. Apollo 13. They didn't land. So this is what it would look like, Apollo 13 going over D.C. So it would have been an aerial view, but it would still have been some exploration, but you can kind of make out Washington, D.C. right there. Next, Apollo 14. Going on. So this is the third moon landing. So again, they barely spent 10 hours out there on the surface. Okay, you can see they had 2 EVAs. One of them took them up to this crater, Cone Crater, way far in the distance, and they made it right up to the rim. Then they had to come all the way back. But one great thing about this this mission, it shows you the idea about priorities. So if you had a limited time in DC, where are you going to go visit? So for Apollo 14, what if they went to the east? Okay, if they landed here and they went to the east, they would be able to go see, some of the different art museums. They'd maybe go visit the Smithsonian Air and Space, and they would make it all the way up to the Capitol here. Okay. But what if they wanted, but they would have missed out on the Washington Monument, Reflecting Pool, and even Lincoln. But if they go to the west, they would be able to get to those, monuments. They would get to World War II monument. They would get halfway down the Reflecting Pool, but they wouldn't have made it all the way to Lincoln Memorial. Okay, and you can see the yellow circle here. That represents the size of the crater that they were visiting compared to the surface area. So you have to have your priorities on your different missions. Where are you going to go and why? So that's what the astronauts and the geologists had to, plan when at these different landing sites. Where do we want to send our astronauts and why? What's gonna be the highest scientific priorities where we're gonna visit? And here's a view. Here's a view to the east from the mall, and you can see what you get the view of the Capitol, or to the west. Which one's more enticing to you? Capitol, monuments. Capitol, monuments. Okay, so you have to make that choice once you get to the surface. Apollo 15. This is one of my most favorite missions. You're looking at the astronaut right here with the rover right on the edge of the crater. Okay, this is a sinuous rill called Hadley Rill, and it was formed by a lava flow that carved a giant channel into the surface. Now, if you look, we haven't seen this before on the other missions. This is the lunar rover, and I had to throw in this quote from Seinfeld. Why don't we fly up to the moon and then drive around? That is the essence of male thinking right there. And what were they doing with the car on the moon? You're on the moon already. Isn't that far enough? Come on. Well, for a geologist, no, it isn't, because the engineers, they want you to land in the safe spots, away from the boulders, away from the cool geology. So they're going to either make you walk, or as a geologist, you have to bring your own field vehicle. So starting with Apollo 15, or the Apollo J missions as they're known, they had lunar rovers, and it was really cool because it folded up like a little transformer, and they tucked it into the side of the lunar module, and they pulled a string, and it kind of popped out and sprung open, and then they had a car ready to go. Okay, so here it is. Here's this giant rill that we were looking at earlier, and then you had their landing site, and they had a couple EVA. They had 3 EVAs going down to these giant mountains, and called the Apennine Mountains. And then they went to the edge of the rill here. Here it is compared to Washington, D.C. If you look, you've noticed we've zoomed out a little more, okay? We've landed them, just off onto the mall, and you have the Potomac River. Now think of that as that giant rill. And that giant rill you see here in blue, okay? Kind of mapped out. So every time you go across, the 14th Street Bridge or something, you're essentially going across Hadley Rill. They're similar, comparable in distance, in width. And so on their first mission, or the first EVA, Apollo 15, they would have made it, across the 14th Street Bridge, down the little running path, and they would have made it all the way down to Reagan Airport. And so one of the cool things down here, and then made it all the way back up. On their second EVA, they would have come down this little, little parks right here, and they would have made it down all the way down to I think it's Bowling Air Force Base. What's cool is this, on the Apollo 15 mission, they collected this thing called the Genesis rock, which is the oldest rocks collected from the lunar surface. It's a piece of the original lunar crust material called anorthosite. And that rock would have been collected right there on the base, right there on the edge of the Potomac there, station here. By the third EVA, they had to cut this one a little short because they had to make sure they could lift off in time. So it's like cutting your vacation short to make sure you're going to make your flight home. And so they made it right up to the edge of the Potomac here, or the edge of the rill on the third EVA, and were able to take some photos. So here it is, looking up the Potomac from the 14th Street Bridge, and here it is, Apollo 15, looking up the lunar rill from one of the last sites. Down here on the bottom, on the far right, you see this is the side of the rill from looking across the river, so to speak, and you see these outcrops in there. And now with our new cameras that we have going all around the moon, you can actually see these outcrops that they photographed in these images. So letter A, that's that rocks right here. B, you can match up the letters D, and that's that little pile of rocks right there. So we can actually map out where they went on the lunar surface with these new images. Apollo 16. Okay, so here's John Young. Look, he's not on the ground. Okay, he's jumping high. This guy's a firecracker, I tell you. He was awesome. Apollo 16, they went to the Descartes Highlands. Here's a view of their landing site, the LEM. Look how it's like a little darker splotch all around there. That's where the regolith, or the lunar soil, was disturbed by the descent engine now as it was coming down. So it blasted away all that dust, and it kind of disturbed it. So now it shows up a little darker in these photography, or in these images. You can trace out these little geophone lines, all their scientific instruments that they left, the ALSET package, the RTG, and right here is their final resting spot for their lunar rover. So you can see where they had their final lunar rover. But look how long. They spent over 20 hours on the surface. Remember, Apollo 11 only spent just over 2.5. These guys are almost doing 10 times that now and traveling, over 26 kilometers total on their EVAs. Just kind of a perspective view. You can see the mountains they visited, Stone Mountain, South Ray, on their EVAs to this cool crater called Gator. I don't know. Way up here you have the Smoky Mountains, as they're called, and They visited a crater called North Ray. So you can see how their EVA plan worked out on the moon at their landing site. But here it is in D.C. So kind of a couple similar areas where they, Apollo 15 visited. But on their third EVA, first EVA, they would have gone to the reflecting pool. So they would have gone right to where the Jefferson Memorial is. On their second EVA, they would have traveled down to the park. They would have been able to say hello to all the people running the Marine Corps Marathon, passing mile 13, which is right around this spot right here. And they would have even made it down to say hello to the troops down at Air Force Base also. On their way up on their third EVA, they would have passed, I think, Dunbar High School is up here somewhere, and they would have made it all the way up to Children's Hospital, which is there. So they would have traversed all the way up there and passed by Union Station and stuff during their EVAs. And what's really cool over here, this thing is called House Rock. And this is one of the sites, and House Rock would have been up towards where Children's Hospital is for Apollo 16. So you can kind of see where they went. They would have stretched almost the boundary limits of the city here. Now here's a view, I guess, looking across the tidal basin that they would have viewed on one of the EVAs looking towards the Washington Monument. Now Apollo 17. Now, Apollo 17 is also one of my favorite missions because it had the only professionally trained geologist on this mission. So their lunar module pilot, Jack Schmidt, he was a professionally trained geologist. Everyone else was a test pilot, military. They had a lot of geology training to get them to the surface so that when they talked back to the scientists, they were given some great scientific information back to the background. Now, you can see some of their, here's their descent stage. Here's where they landed. You can see where they also had some of the similar instruments. They landed in a place called Taurus Littrow Valley, which was this cool valley bounded by some mountains. So it was a valley filled by lava flows, but then it had like older mountains of older lunar crust off to the sides. And they also had one of these lunar rovers for driving around. Now here's a perspective shot of their EVA, of their EVAs. So they also did 3. But again, so they kind of went up to the South Massif, up towards the North Massif, around here, and then did some other sampling down here in the plains of this valley here. So this is really high, these mountains off to the side and to the north, and then this whole little valley is filled in by lava flows. And what's really cool, if you've heard about this shrinking moon lately, this is one of these cool scarps, kind of was involved in that paper there. So this is the Lee Lincoln Scarp, and it's this giant thrust fault that's kind of cutting through the valley and part of the mountains right there. So that's a very special scarp. Now let's look at it on DC. And I've kind of outlined some of the different shapes of where you see the Lee Lincoln Scarp, where you see the Massif. Here's the Lee Lincoln Scarp in green, the North Massif up here. So you can see where those features would have been on the in the city here. Now, their first EVA, they would have gone all the way down. They would have hit the yachts down here, coming up the Potomac. They would have hit the little boatyard stuff. On their third EVA, look, they would have made it across the Potomac, past the Arlington Cemetery around here towards, suburbs of Arlington, Pentagon's right there. They would have made it up. And one of the cool stuff is that this stuff they collected, orange soil, it would have been collected up there in Rosalind at Shorty Crater right there. On their third EVA, they would have gone straight up. They would have passed by the Verizon Center, come around, come by Union Station and stuff, and then, made it back to the mall here. So, but they would never have made it to the baseball field. So they wouldn't have caught a baseball game or even made it out to RFK to catch a soccer game. But you can kind of see how much of the area they were able to get to compared to the other ones. And now here's the later 3 missions, the ones that all had the cars, how much of the city they actually got to explore all together. So if you wrap them all up into one, this is what they're able to look at. So those 3 main missions, including the other ones, which would have barely covered the entire mall if you added those together, this is about all we did during Apollo. We covered Washington, D.C., okay, with these 3 missions. Now if you stretch their length that they went, if you added up the total distance all the way down, they went from D.C., if you add up their, the distance they traveled from every mission, which would be total about 60 miles, they would have made it just past Fredericksburg. If they were going down I-95 here. If they started in D.C., they would have made it all the way down. They would have even made it to Richmond. And here's the state of, Virginia outline. And that's about all it would have come down to. If they had to go up and back, do a round trip, they would have made it down to about Woodbridge or Potomac Mall, essentially. So they really wouldn't have made it too far. So that's, in all our Apollo missions, That's what we were able to cover. A little bit of I-95 in Virginia. So here, just kind of give you a perspective shot of, but it's also amazing how much we actually did get to do. From the first moon landing of barely, covering a patch of grass in the National Mall to actually being able to go into the suburbs and way up into the upper elements of D.C. by driving around. And, from going from 1 EVA for 2.5 hours to 3 EVAs to over 22 hours on the lunar surface, that's amazing. So total Apollo, we did 14 EVAs. We have over 80.5 hours of EVA, moonwalking, and we covered a total distance of over 60 miles on this, which is still pretty impressive. But here's our challenge. So this was said by Jack Schmitt on Apollo 17. Well, I tell you, Gene, I think this next generation ought to accept this as a challenge. Let's see them be footprints like these someday. Okay? So that's your challenge. So I ask you, where will you go on the moon? Do you want to go to volcanoes? Do you want to climb up these cinder cones here and sample the sides of these cool volcanoes? Do you want to go spelunking on the moon? How about these lunar pits or lava tubes? What would it be like underneath those? The giant worms? No. Who knows what's in there? Maybe you can help build the moon base that's actually underground. And how cool would that be? Maybe you could be a cool lunar engineer. Maybe you can come here and look at these sinuous rills. Look at these windy things. This looks like it was formed by a river, but it was a river of lava that was flowing through there. How awesome is that? Imagine just these winding, serene, snake-like river of lava going across the lunar surface. This is awesome. So this is actually at the bottom of a crater in what's called impact melt. So the material that was melted by the impact and kind of molten almost like a lava. This is a bridge. You have a pit here and a pit there, and there's a natural bridge, kind of like what we have in Virginia, a couple other places, just a natural bridge. You could walk across that, which I think even better is if you got a couple astronauts and rovers on either side and jousting and playing a game of chicken across that thing. Who would win? Who's going to end up in these pits that are, 10, 15 meters deep on either side? But these are the things we're now discovering on the moon, pits, natural bridges, more details of rills and, volcanoes and cones. So you can figure out where you want to go, but you also got to figure out, well, how will I explore? Are you just going to get 2 guys in a suit in a car and just drive around like we did in Apollo? Maybe you're going to use robots instead. How about these cool robots? This is triathlete going on at the Desert Rats. Maybe you have robots that help you explore, that, can carry your house with you or your equipment with you. Maybe you can use a cool, snazzy, unpressurized rover, but instead you're standing up, you got more wheels, it's a little tricked out with some gold paint, some spinners. But, that way you can just hop on and hop off, and you can just collect the rocks at your leisure and come back in. But what's even cooler is what I've had a chance to live in. These are the lunar rovers, a pressurized rover. It's almost like a little mini RV, okay? Get your best bud, go driving around the moon, and whenever you want to get out, you hop out the back, go collect some rocks, and you hop back in, make some food, go to the bathroom, whatever you got to do, do a Twitter or something, and then you drive around to your next cool site. What's even cooler is if you had 2 rovers across the sky. What if you had got some more of your friends and you had 2 rovers? How much more of the city could you explore then? How much more? 2 of these things drive around the city. That would be awesome. And what about if you had a moon base? How cool would that be? You dock up, you play some cards or something, have like a family buffet meal, potluck dinner, and then you go back out and you go, tour around the moon. Or even, what if you actually stayed long enough that when all the light went out, you're on the dark side, you're the night side of the moon. Hey, the astronauts on Apollo, they were there during the daylight side of the moon. Wherever they landed, it was always daylight, okay? What if they stayed 14 days? What if they stayed 28 days? What if they stayed 45 days, 60 days, 6 months, a year? What could you get to do versus just 3 days or even a day and a half on the moon? So my challenge to you is that some people think out there that we've been to the moon, we've been there, we've done that. Okay? I challenge you to change that philosophy of thinking. What if we had been there, still there? What if we were on Apollo mission 100 right now? How would this talk be different? Would I be saying, how would Apollo explore DC, or would I say, how would Apollo explore Africa? Big difference. Okay, how would it have explored Australia? Okay, how much further along the moon could we have gone if we had kept going? Would we be on Mars by now if we didn't stop? So just because we've been there doesn't mean we know everything. We've learned a lot, but this is a generation that went there. That wasn't me. It's not my generation. No one in my generation has landed people on the moon. Okay? We have so much more to do and to explore and to learn from it, from science to engineering to just how we sustain life. People love movies like Star Trek and TV shows like Star Trek and Star Wars and Serenity and our Firefly, Battlestar Galactica. If those things are ever going to come reality, we got to stop sitting on our lazy boys and watching these shows, and we actually got to go out and tinker in our backyards, tinker in these engineering things, and we got to send stuff out there. We have to send people out there to create these things, because it's not just going to be invented overnight. There's not an app for inspiration. There's not an app for, I need a lunar lander now. Click. You can't just download it, okay? You have to make it. You have to try. You have to test. You have to fail. And you also have to learn how to succeed, okay? So I challenge you to just never stop exploring, no matter where it is, whether it's the moon, whether it's some of these stars and galaxies that are far, far away that we just can't even get to yet. Some of you guys in here are going to have to be the ones that do that, okay? So I want you guys to make your own footprint. This could be your footprint, you in the NASA hat. This could be your footprint one day. Don't take it off. Don't be shy. Be proud. This is cool. Look at that. What if, like, 30 years from now, someone's giving a talk and they're saying, this is your footprint? That'd be pretty cool, huh? Or your tire track or something. So I thank you very much for your time. And here's some cool, awesome lunar exploration websites that you can go visit to learn more about Apollo or Desert Rats, or what's going on with the Lunar Reconnaissance Orbiter mission and their camera, and just kind of the history of Apollo missions stuff. So I'll thank you for your time, and I'll take any questions. Yes, in the blue fleece. The footprints stay as long as no one's messing them up. So you could actually go to the moon and mess them up, and then they'd be wiped away. So like if your brother drew a picture and you went and you ripped it up, yeah, so then it's gone. So but the moon, because there's no real wind or anything on the moon, there's no water, floods or anything going on up there, they're just gonna stay there. Okay, till an impact crater hits, or till somebody drives over it, or somebody messes it up or sweeps it away. They're just gonna stay there. So you could go back there right now and you would still see all those footprints. Make your own at the same time. Good question. Yeah, I like your enthusiasm. Yes. They do for manned or unmanned, or either. Yeah. Yeah. So, yes. So the question is, do they have a plan for a rover for, I guess, future Mars or manned missions to Mars? That's what we're trying to learn. Apollo didn't have that. They actually did test pressurized type rovers in the 1960s and early 70s of what would it take to take a pressurized rover to the moon during Apollo. But those were just kind of put off to the side. On Mars, it would just kind of depend on the mission. And how much could you take with you to that landing site? How big is your rocket? How much mass are you going to take? How many launches is it going to take to get all your equipment, to that particular mission? Is it an option? Yes, but just kind of how to make it feasible. That's sort of what we're testing in NASA Desert Rats. How do you make an efficient rover, for living in, for 2 people, 3 people, 4 people to live in, and what does it take to make that rover? And then how can we send it to these different planetary bodies, to the moon, to an asteroid, or to to Mars? So the idea is on the table, yes, but would it be on the first manned mission to Mars? That would be tough to say. In the front and then in the orange. How would we get a base to the moon? Well, one of those, they're working on several different ideas. One is you launch it in pieces, and you would connect it either using different robots. So before you got there on your mission, these pieces, like Lego pieces, would launch, and they would land, and they would connect them, teleoperate from the Earth, either using robots or something, and connect those pieces of the base together. And so when you got to the moon, it would be ready to go for you. So that's one idea of how you might get the bases there. You'd have to do it in pieces. You ever drive down the road and you see like half a house, driving down the road? It'd be like that. You have the half a house and you got to connect them, okay? And you do that and send half a base and half a moon base and connect it together on the moon, or connect the different modules. So similar, how we built the space station above, it's all been done in pieces, right? So we have several shuttle launches to launch up each of the separate pieces that we kind of continued to attach a little bit at a time over the last decade or so. So that's how we might do a moon base. And in the orange, you had a question. Oh, that was probably most of them. Okay, so the question is, for those of you who might be listening online, the question is, who is the video of the astronaut jumping along and then all of a sudden fell down face first? And the thing about, I think most of them probably fell. Which particular video you're talking about might be Apollo 15 or Apollo 17 is what I'm thinking of. So it might be Eugene Cernan or Jack Schmidt or Dave Scott or somebody. But what was neat about their suits, though, is that they had their center of gravity, so they're kind of lurched forward. So they're almost like a little bit on their toes or tippy toes all the time. So they're kind of leaning forward just a little bit. So, and you can't really see if you've ever put one of these suits on. It's really hard to see where your feet are. Kind of looking down, you're kind of looking out. It's almost like having a football, helmet on or something. And so you might trip over a rock, and then you're bouncing a lot. So you're almost like on little trampolines. So you're bouncing and bouncing and bouncing, and then you might just enough, you hit a rock or you get enough momentum, you just fall forward. But they were able to bounce themselves pretty much right back up. What they didn't want to do is land on their back, because then you're like a turtle, and you're sitting there waving your feet and waving your arm, and you're trying to figure out, how do I get up? And then you don't want to bend over. You don't want to be the guy bending. Then if you fall down, then both of you guys. So then it's a real mess. But so I think most of them probably fell. I mean, got dust all over them, but it was good. You don't want to fall, but I think most of them did. But it was also, just the way they were balancing, getting used to the suit, the center of gravity of the suit, and stuff like that. So I'm sure you will fall on the moon. I'm sure I would fall on the moon. It'd be fun, though. Yes, in the red. So the question is, for those listening online, can we use the ISS to launch spaceships to the moon and to launch eventually from the moon spaceships to Mars? They have ideas for doing that. So the way the current ISS is configured, I don't think it's meant or built for doing that kind of space operations. And they might be able to add things to it that they could, but I don't think it's designed to do something like that at the moment. But there are ideas of just saying, hey, let's keep a spaceship in space. It doesn't continue to launch from Earth and to the moon. It just stays in space, and it's like a little space shuttle or capsule that you might see in Star Wars that ferries people back and forth to the lunar surface. Now, launching from the moon, is that an option? Yes, but also you got to figure out, how do you get all the resources, and you have to build your launch pad there. You have to get all your fuels and propellants there too. So a lot of it, it's not that it's impossible, but the logistics of it at the moment are just hard to figure out, I guess. Yes, I totally agree with you. You have it right on the ball there. There's no atmospheric drag to get out, and your escape velocity is a lot less than it is here on Earth, because it is that lower gravity. So maybe one day, I mean, that's how we can do it. Maybe, we have to figure out how we can, get from one place to the other by using the moon as an intermediary step. So, but the only way we can figure it out is if we go try to test it too. So, I mean, I think that's kind of part of it is we got to try these things. They look great on napkins and they look cool in PowerPoint, but, until you actually try to figure out and try it, in real life, you just never know. So you learn new things by actually physically trying it. Yes? Billions. No, I don't know. So the question is, how many moon volcanoes are there? That's a good question because on the moon, it's very difficult to find all the volcanoes. So there's one cool place called Marius Hill. So an exact number, I don't know, but it's a lot, probably in the hundreds, if not even thousands. There's a really cool place. It's called Marius Hills, and it's a field of little volcanoes all over the place, almost like you would see out where we just were out in Flagstaff, Arizona. There's all these like little cinder cone type, volcanoes. Excuse me? Did they hurt each other? Oh, burn each other. Yeah, so some of these volcanoes, so Marius Hills is a field of volcanic, domes or cones out there. And some of them, they can, quote, like you're asking, burn each other. They might form right next to each other. Okay, so you have one that formed, and then right next to it, the little other volcano is coming up a little later is like, hey, I like that spot too, move over. And then like might build itself right on top of that other one or help, even partially destroy that other volcano. So they can kind of form right around the same spot and, form on top of each other. So essentially they would sort of burn each other, I guess. Yes, ma'am. Yes. So this is a new development. I know, exactly. I didn't either. But so I've just been, so the question is asking about volcanism on asteroids and, how that can happen. And so there's a mission called Dawn, and it is actually on its way now. It launched several years ago, and it's on its way to an asteroid called Vesta. Okay, in Vesta, we actually have samples of this asteroid that we have here on Earth that we can, using the chemistry of the meteorite samples that we have and kind of the spectral chemistry that we can determine from the asteroid, we can relate them to each other. So we know this sample is from this asteroid, and based on that meteorite sample, we've deduced that there has been volcanic activity on that asteroid. Now, so this mission, Dawn, is actually on its way, and this time next summer, next year, we'll be going in orbit around this asteroid. So it's not even just going to fly by and take a few photos. It's actually going to map it, and in fairly good detail of this asteroid. What's even cooler is, so part of my job, I was just been selected as a participating scientist on this. So there's people who've been involved with this mission for a long time, for decades actually, getting this mission off the ground and actually, to the asteroid and making it a success. And then they brought on a group of scientists now as the mission is getting closer to the target area. And so my job as a volcanologist will be to hopefully look at the morphology here. And it might be very thin and minute, and it might be very subtle, but we're going to look for what volcanic features may or may not be still preserved on this asteroid and try to understand its volcanic history. And then, yeah, it's in the asteroid belt, and it's, a couple 100 kilometers in diameter. So it's a pretty big chunk of rock. But what's even cooler is after it's done with this asteroid, it's going to go off to another one called Ceres, which has more of like a fluvial nature to it, and it's going to compare and contrast these two different types of, asteroids. So look for the Dawn mission this time next year, exploring, the asteroid Vesta. So yes, way in the back there. That's a good question. We should send you to the moon so you can find out for us. Okay, so the question is, are the lava pits, so these kind of circular holes into the ground that we've been noticing on the lunar surface, let me see if I can find one. Nope. There it is. Okay, so the idea is this just a hole in the ground and maybe it just kind of goes a little bit over here, off to the sides, or is it actually a tunnel system? And that's the question. We don't know. I mean, we can kind of slew the, angle the spacecraft to look a little bit underneath, but we can't tell what's actually going on if it is like a cavern system or a lava tube system underneath the surface just yet. In my experience as a volcanologist walking around lava flows, it could be either. And it's just hard to tell what just by looking at the surface. We walk around lava flows, my colleagues and I, and we'll just see a pit. It'll look just like this, be nice and circular. There'll be, boulders on the ground, but it would only go maybe a couple meters back. So you wouldn't see anything else. You would just see a void, a pit. The other times I've been, and you can walk in and it's just a giant lava tube. Okay, so you see area skylight called, and then if you actually got down the bottom, you could walk on, for kilometers, even hundreds of meters, if not kilometers. So that's the question. That is a good question. That's why we know what reasons why to go back is, what is going on underneath the surface? Is it a pit or is it a big cavern system formed by lava flows? So that's a great question. NASA hat. Okay, so the question is, how many craters are there on the moon? That is a question I hope I never have to answer or find out what the answer is. It's like a Tootsie Pop question. The world may never know, okay? So there are, I don't even know what to say. I don't even say millions or hundreds of thousands or, I mean, the thing about craters is they happen at all different scales. So some of them are the size of states, if not, the size of the United States. Some are that big. Okay, some of them are the size of an M&M, Skittle, or a piece of candy. That's the size of craters. Look at all these little craters. You could keep going down and zooming into the surface, and you would just find craters of all different sizes. Yes, and in my profession, there are people who actually count craters, and we use that to try to determine the age of the surface. So think of it as craters as being wrinkles. Okay, if a person has a few wrinkles, they might be kind of young. If people have a little more few wrinkles, they might be very, very wise. I'm choosing my words wisely here. Okay, so we use that. So we usually call them undergraduates. We'll sit there and count craters for the people who have the money to pay them to count the craters. So it's almost infinite or something. I really don't know an exact answer, but there's a lot, and there's almost too many. Okay. Good. I know. You're stumping me. Yes, sir. In the front. So the question is, if we're looking at this pit that we're looking at here, could we send a robot down into the pit to see if there is a tunnel or, just a pit there itself? And yes, that is a great idea. So, or an undergraduate. I don't know. If I'm going to the moon, I'm gonna get the glory. I'm gonna make him hold the rope. But yeah, that is a great idea. So, the question is, what kind of robot what would this robot look like? Would it be spidery? Would it be like a bouncy ball? Or would it go down on a line like a Spider-Man, or something? Would you just toss it in there and hope for the best? So that would be your project to do in grad school, is to design the robot that goes to discover the tube system. Okay. I see one way in the back, or a couple in the Okay, so the question is, has there ever been any evidence for any life forms on the moon? And not to my knowledge. So from the samples we brought back, there has not been any evidence, kind of like the Mars meteorite that has always been in the news. There has nothing been discovered in any of the lunar samples that would, I guess, be representative of a life form or life. And the person next in the white, yes? You have a great question, and so you should join one of the science teams. So the question is there any other benefit besides knowing the age of the surface of knowing how many craters there are on the surface? And for mainly kind of a hazard of like what's the impact flux or what is maybe a hazard for a certain area or for the moon. And we actually have, so part of some of the scientists on the LROC team and even other lunar scientists, what they have done, one of the things they've done is they're comparing Apollo images and comparing some of the new images that we're getting from like LROC, so to speak, and actually looking, putting the new image over the old image, and they do this, it's called a flicker, so you kind of old, new, old, new, old, new, kind of like, flip it back and forth, and they're actually seeing where we're getting new craters on the surface of the moon. Now, it's a long and tedious process, but like you're saying, yes, that would be great to know for hazards, for what is the current rate of impacts and what size of these things are hitting the surface of the moon, and is this a danger for if we ever sent humans back and or had a moon base? What will we actually need to bury it? Will we need it in one of these pits? That is a great question and is actually a question that scientists are currently working on. Yes, in the red. Yeah. That on the moon, that would be tough. I really don't know the answer. My hunch, my gut feeling is no, but that's just a gut feeling, and you never know until you try to look, or you never know till you look, or try to look. And so, but you just never know what's out there. You don't know what's on Mars. You don't know what's on some of these other moons around, Jupiter or Saturn. So you just never know what's out there till you look. And that's part of NASA's quest is to look for, life or signs of life outside of Earth. So, yes, sir, in the back. Yes, and that's so the question is if there's any resources for manufacturing like a fuel or something on the moon. Scientists and engineers are doing studies called in situ resource utilization (ISRU), and so the idea they've basically done some analog field testing up on Mauna Kea in Hawaii, kind of during the summers, and their goal is to develop like equipment, machinery, robots that can take soil, lunar soil, lunar regolith, and process it, the materials, so that it does form a type of fuel or something or oxygen, and something that can be used by the astronauts, on the surface for a fuel or for to help run their habitats and stuff. So I don't know all the details of it, but yes, they are trying to figure out what can be used on the surface. Yes, sir. Ooh, so the question is, what country might be next with a manned mission to the moon? My hope would be the United States, but I know China is working hard to send humans to, they're working on their own manned space program. I'm sure at some point, I don't know how soon, but I'm sure their goal would be to land one of their countrymen on the moon one day. So that could be, you know, where it is right now. So it could be China, could be United States, could be someone else. I really don't know. So, but those are the, yes, sir, in the red. So the question is, next time we land somebody on the moon, would we go somewhere where we've been before, or would we try to land somewhere new? My guess would be we would try to land somewhere new. Mainly, there's a lot of people who are advocating for an area near the South Pole because there's permanent illumination down there. It might be a good place to, try to set up a lunar base, and it also gives us scientific, access to understanding some of the earliest, impact events of the lunar on the lunar surface. So in what's called South Pole Aitken Basin. area. So my guess we would go somewhere new, but it also would depend on the type of mission. I think at some point we would visit places we've been before, just because I don't think we got to do everything we wanted to do there. Might not the exact same landing site, but maybe 10 kilometers away or 2 kilometers away or something. Maybe go retrieve an artifact for the museum or something. Yeah, I would say like Australia. I would say if you were landing once in DC, like if you wanted to land in some of these other polar locations, it would be like going almost all the way down to Australia or Antarctica. I mean, it would be a world of difference. If you look at the landing sites for the moon, they're all kind of clustered towards the equator. Oh, this one, yeah. So if you look up here, you see all the red dots. They're kind of clustered towards the equator. Most of them, 16 is the one most to the south, and I think 15 or 17 is the most to the north. I think 15. So they're kind of clustered. So South Pole Aitken Basin will be on the opposite side and kind of down towards the pole area. So it'd be a whole new world down there. More possible questions? 12 to 14, good question. So we're going to go back some. And so Apollo 11 was the first moon landing. So the question is, why does it go from Apollo 12 to Apollo 14? So there was Apollo 12, okay, and then it launched. And then there was something called Apollo 13. Apollo 13, it had 3 crew members, and their goal was to land on the moon. But something kind of funny, tragic happened on the way to the moon. And if you look at their spacecraft here, look at that. That doesn't look natural, does it? See how it's nice and smooth and shiny? That's kind of a little kind of broken up and rubbly and torn up. So they had a small explosion in quotes, on their spacecraft. And so because that happened, they were losing a lot of their oxygen and resources and their power. And so they had to cancel their moon landing. But what was neat is that they made it back. So what they did, they lived in the lunar lander actually for several days. And here's the 3 astronauts up here, Fred, Jim, and Jack. Okay. Jim Lovell was the commander. There's a neat movie called Apollo 13 about this. And over here these are them after the mission getting back safely on the aircraft carrier. And here's everyone in mission control up in the upper right cheering them on. So there's everyone. So it was the mission didn't happen, but it was a success and a triumph that we actually saved them. There was a lot of teamwork and a lot of neat ingenuity that went on to make sure these astronauts made it back alive. So that's why they're on the landing map, you only see 12 and 14, you don't see, because they had a little accident on the way to the moon. They weren't allowed to land on it. Okay. Yes, sir. Okay. So the question is, in desert rats, are we looking at how we can deal with the incredibly abrasive dust with the suit systems and just in the vehicles? Yes, and I'll say yes and no. As far as yes, one of the things that I'm going to flip to some of the shots here. One of the things that the astronauts did on Apollo is they were in their suits all day long for 6, 7, 8 hours. And when they had to come back in, they actually had to get in their entire suit and bring that back into their house. So it's like, dragging your muddy shoes into your grandmother's, foyer. And she's like, what? Get out, back to the porch or something. Okay. So they had to bring all that dust back into their living quarters. On desert rats, one of the things we're learning about and testing is what's called a suit port. So over here, you see the back of the rover, and underneath that canopy there, that actually lifts up like a little awning or garage door. And beneath that are actual spacesuits. So it's the spacesuit. So the idea is that you would actually climb in through the back, inside the rover, and through the backpack, and slip yourself into the suit, close up that hatch, and then step off. And then you're ready to go. And then when you're ready, you dock yourself back in with the backpack and climb back out through the suit. So that's one of the ways we're trying to test engineering-wise of how we can keep dust out. There's a few other things we have to do, but the ideas are on the table. But as far as the fully functioning pieces of equipment that will take the dust away, that's still, still needs to be developed. But the ideas are there, and people are kind of working on ideas of how to mitigate it. So in that sense, a yes. But here it's the fidelity of it, it's still really high, but as far as the dust mitigation fidelity, it's we're still working on that. Mm-hmm. 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 Yes. Yes, and that is a great comment. So for everyone listening, go to, it's moonzoo.org, I believe, and you will look at actual images of the moon from the Lunar Reconnaissance Orbiter camera, and you get to do the science. So you are the scientist on that website, and you get to count craters, you get to look for artifacts, you get to look for volcanoes and rills and all kinds of other geologic features. So go to moonzoo, I believe, .org, and become a citizen scientist on the moon.
Along with Moonzoo, actually, there is a special challenge for this event, for International Observe the Moon Night. So right now, they're trying to classify as much of the lunar surface as they can, but specifically the size of like the Dead Sea is what they presented. I think it's over the course of 2 days, I think. And okay, so they wanted to do 60,000 images, and it runs until the 19th, and they're trying to get as many people involved as they can. So thank you for that plug for Moonzoo. That's a wonderful, wonderful website, and the citizen science is really great. So help us out. And the scientists really use that information. They really do. So
yeah, thank you very much for mentioning that. Thank you guys very much for your time, and I appreciate it. I hope you guys enjoyed International Observe the Moon Night. So have a good evening.
Yes, and thanks to all of you online for listening.